Okay, so today we're moving on to a new series, a new module, which will be what you've all been waiting for: building smart contract using Soroban. So building smart contract on Stellar using Soroban. So there are two forms of application you can build on Stellar. You can build an application that not really a smart contract application, but an application that can send transactions and also view all transactions. And for that, you'll only need to use the Horizon API to do that. But then when we deal with smart contract, then you use another endpoint, which is the RPC. Like I spoke about it in the previous classes. But today, in this series, in this module, we'll focus on smart contract. So let me share the screen. Okay. So this is an introduction to smart contract on Stellar blockchain. So I got this course from Adebara Ayomide. He's another blockchain developer. He also works with Stellar. So I got the slides from him. So this is an introduction to Stellar smart contract, what you've all been waiting for. But before we go further, let's first start by we need to all understand what is a smart contract. So a smart contract is a self-executing contract where the terms of the agreement are directly written into lines of code. This contract automatically execute and enforce the terms and conditions laid out within them when predefined conditions are met. On the Stellar network, smart contracts are pieces of code that runs on this blockchain and can facilitate, verify, and enforce the negotiation or performance of a contract. So what's an example of a smart contract? Let me give you an example. You can create a smart contract that can have like a number of people who have to agree on a certain transaction. Like for example, you're working in a business and you have funding somewhere, but before a transaction is authorized, you want three people to sign. If it's only two out of the three people, the transaction is not going to go through. So we can create a smart contract that does exactly that. That enforces the rules and the law that three people have to sign before this specific transaction goes through. So this is an example of a smart contract. And another example that is pretty common right now is betting. There's a lot of smart contract betting platforms where you select your teams, and according to what do you call it? So, for example, you select a team, and then the odds are like 2, or the odds are 3. So maybe you selected a team, and the odds were like 3, meaning that whatever you put in is going to be tripled. So if a smart contract platform, it's possible to create an application that will automatically pay out the person who wins the bet. You understand? So this can also be done in smart contract. And there's also what we call an oracle. So oracle are also platforms that are used by blockchain like Ethereum, even Stellar. So one of them, the example is Chain. I think it's Chainlink. Yeah, Chainlink is one of the oracles. So how they work is they have data from all over the world. For example, the price of dollar, the price of different currencies, the weather, sports, what's happening in soccer, and all that. They have all those data. So when you create a smart contract, you can also use Oracle to work hand in hand with the platform that you have created. For example, if you want to get accurate information about the price of a currency or the weather or sport, for example. So you can use an oracle for that. And so today, okay, we're learning about smart contract, and I'm introducing you to Soroban. So Soroban is a smart contract platform integrated into the Stellar core protocol. It enhances the functionality of the Stellar network by allowing developers to write and deploy smart contract. It was named after the traditional Japanese abacus. Soroban brings precision and efficiency to the Stellar ecosystem. So before 2022, there was no such thing as smart contract on the Stellar blockchain. So it was implemented from 2022, and it's added a new layer on the blockchain itself. Because before 2022, Stellar was just about transaction, like sending crypto, sending transaction, receiving crypto, and so on and so forth. But with Soroban was an evolution of the Stellar blockchain itself, where there's now a layer on top of on top of that blockchain where you could create smart contracts. So what's the importance of smart contracts in blockchain? So smart contracts automate processes, reducing the need of intermediaries and thus lowering transaction costs. They enhance transparency and trust since all transactions are recorded on the blockchain. Smart contracts provide increased security by eliminating the potential for manual errors and fraud. So these are some of the uses and why it's also important. So what is Soroban? So Soroban is the Stellar's native smart contract platform designed to leverage the network's inherent strengths such as speed, cost efficiency, and scalability. It allows developers to write decentralized applications, dApps, that can run on the Stellar blockchain, thereby broadening the scope of what can be achieved on the Stellar network. So the key features of Soroban, it's the secure execution, ensuring that smart contracts run in a secure, isolated environment, low-cost transactions. You've heard a lot about this. Scalability, it's designed to handle a large number of transactions and contract executions efficiently, and developer-friendly. It supports multiple programming languages and provide comprehensive documentation. So it's not only Rust. You don't have to use Rust. You can also use Python as well and other languages, as long as you can convert it into WASM, which we're going to talk about. So the benefit of using Soroban on Stellar, enhanced functionality. It adds complex programmable logic to the Stellar network, allowing for more sophisticated financial products and services, robust infrastructure. It's built on a mature and well-established Stellar network, ensuring reliability and stability. So this is something that we can really believe in, because Stellar has been here for years and it has good reputation. So we show that we can create an application, a smart contract that on a system that is reliable. There's also community and ecosystem support, leverages Stellar's strong community and ecosystem, providing ample resources and support for developers. So hence, now I'm going to explain something so important: WebAssembly. So WebAssembly is a binary instruction format for stack-based virtual machines. It is designed to be a portable compilation target for programming languages, enabling code to run on various platforms without modification. WASM is known for its efficiency, security, and performance, making it an ideal choice for executing smart contracts on the blockchain. So what is WASM? When you write a smart contract using Rust and you compile it on your machine, which I'm going to show, it's going to create a WASM bytecode. So a file that is like a .wasm that has all the instructions, and it basically has all the logic, but in a very small file that you can also use to upload on the blockchain. But you don't upload the WASM itself, you upload the hash that comes from, because every WASM has a hash. So that's where a unique hash. So that's where it gets all the information, all the contract information. So we're gonna get deeper into that. So smart contract written by developers are compiled into WASM bytecode, which can then be executed on the Stellar network. The compiled WASM bytecode is stored on the ledger, allowing to be retrieved and executed as needed. This integration ensures that smart contracts are executed quickly and securely with minimal overhead. So the benefit of WASM for smart contracts, high performance, designed for fast execution, language agnostic, meaning that you can write smart contracts in various programming languages that compile to WASM, providing flexibility and ease of use, and then the security. WASM design includes strong security features such as sandboxing, which isolate the execution of smart contract from the rest of the system. So there's going to be a lot of things here, but I'm going to quickly just go through it. So the contract installation process. So first, these are the steps you take to create a contract. So developers write a smart contract code in the preferred programming languages. Excuse me. So here we're using Rust. So the written code is then compiled into WASM bytecode, creating a binary executable file that can be deployed in a Stellar network. So once compiled, the WASM bytecode is uploaded to the Stellar network. A contract data ledger entry is created to store the binary data of the smart contract. This entry includes a unique identifier, which is the hash of the executable file. The hash of the executable file, has a unique, serves as a unique identifier, ensuring that each smart contract is distinct. The binary executable is stored separately from the deployed contract itself. Is separated from the deployed contract instances, allowing for reuse and efficient management of smart contract code on a network. So contract invocation and execution. So how transaction invoke smart contract. Transaction on the Stellar network can include operation that invoke smart contract functions. When a transaction attempt to call a smart contract function, the WASM bytecode for the contract is retrieved from the ledger. So retrieving WASM bytecode from the ledger, the network fetches the stored WASM bytecode based on the unique identifier associated with smart contract. This ensures that the correct version of the smart contract code is executed. And then there's a secure isolated runtime virtual machine. There's a secure isolated runtime virtual machine is instantiated to execute the WASM bytecode. So this is the virtual machine that on the Stellar blockchain that execute the code. So the virtual machine environment ensures that the smart contract runs securely with no risk of affecting other operation on the network. So once an execution is complete, the VM exits, maintaining the integrity and security of the blockchain. So here, something you have to understand, there's contract instances. So whenever you deploy on the Stellar blockchain, you create a contract instance. So you can create many contract instances with the same code that you have created. So let's say I create a code, I'll compile it, and then I'm going to have the WASM bytecode. And once I have the WASM bytecode, I can then deploy it to the blockchain. So once I deploy it to the blockchain, then that's just going to be a single instance of the code itself. So if I deploy it again, it's going to be a different instance. They'll have the same structure. They have all the WASM will have the same structure, the same instructions, the same functions, and all that, but they're going to be different instances. So let me explain. So after the executable bytecode is installed on the Stellar network, contract instances can be deployed. These instances reference the installed bytecode by function independently. So the relationship between executable code and instances. So a single executed bytecode can be shared by multiple contracts. So you can create a code once and you can have different instances. Each instance maintain its own data, state data, while sharing the same executable code. Contract instances operate independently despite the use of the same bytecode. This allows for scalable and flexibility deployment of smart contract. And another thing you have to know about smart contract is the storage. There are different storages when you deal with smart contract. Smart contract on Stellar can utilize different type of storage to manage the state and data. The main type of storage include temporary storage, persistent storage, and instant storage. The name itself can give you the meaning of what it's all about, because you see, we're talking about temporary, we're talking about persistent, we're talking about instance. So it's kind of like give us an idea what it's all about. So the importance of storage in smart contracts. Proper storage management is crucial for the functionality and efficiency of a smart contract. Different storage type cater to different needs and use cases, providing flexibility for developers. So far, like from the first classes, we learn about blockchain itself. We learned that blockchain has the list of ledgers. Blockchain is ledgers that runs on multiple computers, copies of ledgers on multiple computers, and those ledgers can keep getting bigger and bigger and bigger with all those data. But you can also imagine that some of the data might not be useful anymore. You might have created an app that sees the price of maybe current price of dollars, maybe in 2026, or maybe the price of dollar, sorry, not 2025, for example, or maybe sport, you wanted to use the Oracle to just see the current score of a team, for example, and you don't want to use that data ever again. You just want to use it at that instant, maybe to pay out someone who was using your smart contract betting platform, for example. Then you don't need to have data that will stay for years. That's just unnecessary. So that's how Stellar tried to solve this. You might have deployed an application, but you don't use it anymore. Maybe you just created an application just to test out features. Maybe you wanted to test out your application in the real world on the mainnet, for example, but then you don't ever use it again. So that's why you have to understand how that's why Stellar, compared to other blockchain like Ethereum, decide to have different categories of storage to deal with bloating in the network itself. So here are the different type of storage. There is the temporary storage. So temporary storage is used for data that is short-lived and does not need to be preserved permanently. It is the most cost-effective storage option on the Stellar network. If you want to see the fee structure, let me see. So we spoke about it in one of our previous class, like how to calculate all the fees, because every transactions that happens in a Stellar blockchain costs some lumens, but a very tiny fraction of lumens. So you have to bear that in mind. And even when you're calling a function, when you call function calls as well, or when you're changing, maybe you're adding a new user in your platform, your smart contract platform that you have created, that changes data, for example, that's a transaction and it costs some lumens. So a temporary storage is the most cost-effective storage option, and it's the lowest fee compared to other storage types. This makes it ideal for storing data that does not need to be retained long term. And the use case for temporary storage is suitable for time-bound data such as price oracles, signatures, or any data that can be easily recreated. It is ideal for scenarios where data is needed for a short period of time and can be deleted once its purpose is fulfilled. So this is type number one, and then there's persistent storage. As you can see by its name, persistent storage is used for data that needs to be retained for a longer period of time and is critical for contract functionality. It's more expensive than temporary storage, but ensures that the data can be stored and that ensures that the data can be restored if needed. The fee structure, persistent storage incurs higher fees compared to temporary storage, reflecting its importance and durability. The use case for persistent storage suitable for storing user data that cannot be temporary, such as balances, user profiles, or any critical contract data that must be retained. This is ideal for applications where data integrity and longevity are crucial. And then the last type of storage is the instant storage. So instant storage is a specialized form of persistent storage tied to the life cycle of the contract instance. It functions similarly to persistent storage, but has limited amount of storage available. Instant storage incurs the same fees as persistent storage. This reflects the importance of maintaining the contract instances state throughout its life cycle. So the use case is suitable for storing shared contract states such as admin account, contract metadata, and other essential data. This ensures that the state of the contract instance is maintained and accessible for as long as the instance is active. And we're not going to go through this. This we can go through later. And okay, so what are some of the use cases of smart contract? In the real world, use cases of smart contract on Stellar. We have decentralized finance. Smart contract can automate lending, borrowing, and trading of financial assets on the Stellar network. There's asset tokenization, which enables the creation and management of tokenized assets such as real estate, commodities, and other financial instruments. Supply chain management restricts the movement of status of goods in the supply chain, ensuring transparency and efficiency. And then there's insurance. Automate insurance, claims, processing, and payout based on predefined conditions and events. So these are some of the case studies and some of the things that you can think about when you're creating a smart contract, and some of the solutions that you can create using smart contract. So another thing that you also need to be aware of is developer resources. I'm going to post them, every resource possible this week. So we have the Stellar SDK, which provide libraries for various programming languages, enabling developers to interact with the Stellar network easily. There's also the Soroban playground and online environment, like this one, for example, where you can write smart contract and test them and see how it works. And where was I? Here. And we have the Horizon API, which allows developers to access and interact with the Stellar network, retrieving data and submitting transactions. So here you don't really need to create a smart contract to do this, to retrieve data and submit transactions. So the best practice for developing on Soroban, so you have to ensure that your code is audited before you can deploy it. You also have to test it on the testnet, because we have the testnet is a sandbox environment that you can use before you deploy to the main network. And you also have to stay updated with the latest development and best practices in a Stellar and blockchain community. communities. And also, let's go here. I just want to show you something. So Stellar blockchain had an update recently. They had an update recently, and this also reflected in the Soroban SDK. So when you install it, then there's new things that you could do that you could not do before. I haven't read through everything, but there's just an overview of some changes. So it's this protocol 23, and more information can be found in the Stellar official website. I just wanted to show you this very quickly. Okay, so this was basically an introduction to smart contract and something that you have to keep in mind before you even start coding. So now let's get into coding. Let's get into Soroban itself. Let's get started. So what is Soroban? So a quick recap. Soroban is still a smart contract platform. Smart contracts are small programs that live on the blockchain and run automatically when called. Example, instead of trusting a person to send you money when you send goods, a smart contract can hold the funds and release them only when conditions are met. So why Rust and Soroban SDK? Soroban contracts are written in Rust because it's safe and memory efficient. Remember, you can use other languages, you can use Python as long as you can convert it to WASM. But when you use Rust, Rust is just much more safe. It is much more memory efficient to do what you want to do. Contract compile into WASM, WebAssembly, so they can run on different platforms in a controlled environment. The Soroban SDK gives us special tools. This is something that you have to like note in your mind. The Soroban SDK uses special tools like the env, the environment, string, vector, that works in the blockchain world. So let's get started with the code. Before we even start writing our first smart contract, we have to install. There's some installation that we have to do. Let me just copy this. You have to install some stuff. Okay, the first thing that you do, the tool that you need is the Rust toolchain. By now you have Rust. The editor, which I also think that I believe you have an editor. The only thing that is missing is the Stellar CLI. So install Rust. After you install Rust, you make sure you have the editor. And once you open your editor, look at what do you call it? Let me show you. Extensions. When you go to extensions here, you search for Rust Analyzer and Code LLB. I don't have Code LLB. Let me search. So this one I help you with debugging. Code LLDB. So I'm going to install it. Yeah. Come on. Okay, let me trust this installer. Okay, fine. So you also have to have code LLB. So once you have that, you now install Stellar CLI. So if you have this, like I have the Ubuntu on my Windows, then you can install here just by copying and paste this code. But if you don't have brew, if you do this and brew is not installed, you can use the brew command, then you can go to this website brew.sh, and you install just by simply copying this, and then you're going to install it. So once you have brew installed, you'll be able to install Stellar this way. So I have Stellar installed already. Let me just even check the version. Stellar version. Okay, I have version 32. So I actually updated it today. Protocol 23. So you can also you can also use this to install if you want to install directly. Another thing that you also need to do is to set up your profile, your identity. So your identity is basically your wallet, the wallet that you're going to use to be able to do transactions. So your wallet on the test net. You can also use it in the you can also use it on the mainnet, that the wallet you're going to create. So to create a wallet, you use this command here. So here's Stellar key generate global Alice network fund. So Alice is just a name that you've created. That's going to stand for a wallet. So Alice is going to have a wallet address. So let's try here. It's pretty not gonna work because I have Alice already. I've already created so I have to create another name. I talk so much. Let me just pause. I hope everyone is understanding where we are so far. Like if you have a question, you can pause me. If you have a question or if you're stuck. Yes, Mohammed.
Ben, you're writing the code where exactly? In code VS or in
Yeah,
other?
I haven't yet written the code. I'm just setting up. Yeah, I'm using VS Code to write code. But here, this is my terminal. I don't know which terminal you use.
Okay.
Yeah, this is my terminal where I used to install. I don't know if you are using Windows. Are you using Windows?
Okay.
So this is my terminal. So I'm just showing you how to set up Stellar CLI. So to be able to write smart contract. So the first step was to install Rust, which we have already done. To install the Visual Studio Code, your editor, and then install these extensions, Rust Analyzer in your VS Code and code LLDB on a VS Code. And we are in this step here. I've already done this, which is installing the Stellar CLI. If I could show you now, it's gonna take me like tens of minutes. So I did that already. So after doing that, then you have to create a profile or a wallet, a wallet that you're going to be using, because you're gonna be creating smart contracts. So you wanna be able to test your smart contract using a wallet. For example, if you wanna have a smart contract that's gonna be sending maybe transactions or whatever it is, you need to have a wallet to interact with it. So to do that, you use this code right here, like Stellar this command, Stellar keys generate global Alice network testnet, and then fund. Fund is basically giving it some funds that you'll be able to use. I think it's going to be 10,000 fake XLM. So that's how we do it. So I created one called Alice, but I can't because I already have that identity in my machine. So I can call it, let me give him another name. Let me say Alan. Oh, that's already used as well. Global is replicated. Global is always used. Okay. Account element funded on text test SDF network. Yeah, I think global is no longer used in a new Stellar CLI. So it's, if I remove that, if I just use this code without the global, it's still going to be working. So it's not really necessary to use the global. All right, so now to see the address of what I've created, of the wallet that I've created, you just type Stellar keys address Alan. So if I do that, I'm going to see my address. No, I mistype it, Stellar. And this is my address. As you might know by now, Stellar address only starts with G. Stellar addresses only start with G. So this is my address. So I have my identity sorted. And yeah, that's basically how you set up how you install Stellar CLI. Now you're ready to code. You're ready to code now. So let's start doing it. Let me just close my thing here. Oh, sorry guys, I lost you. Can y'all hear me? Can y'all hear me? Okay. All right. So now the next step is we're now going to start our project. So let me first create a folder. So this is my folder. So let me enter that folder. And the first step that we do is we're going to do this, use this code here, Stellar contract init Soroban hello world. So this is just going to create a project, a folder of a project called Soroban hello world. So that's what we're going to be doing here. And then as you can see, we have it in our folder. So let's enter that folder, and then we're going to see what. Righty. So this, after creating the project, this is what you're going to have in your folders. You're going to have cargo log, cargo.2ml, the readme, and then contract. The contract will have hello world, what we created, and all this. And this is the SRC is where your code are going to be stored. There's going to be two Rust files, lib.rs and the test file that's going to test your code to make sure everything works accordingly. So let's look at it. So it's loading. I hope you can see my screen. Okay, it shows. Wow, okay, I see it. Okay, so once you've created, you're going to have two files. You have the file that is the main code, and it'll come with wow, this is different, hey? It's a little bit different from the previous the previous code that came automatically once you create a project. So this is the code that you're going to see. It's a hello world, and you can use it to play around with it. Let's see the terminal, and I'm going to explain the code line by line. Let it load a little bit. Okay, so the most important thing that you need to know here, whenever you're creating a smart contract on Soroban, is this line here called no STD, which means no standard library. So the no standard library, what it basically says is don't use Rust standard library, because the Rust standard library is very large, and we're dealing with blockchain. We want to be as efficient as possible. So we're not going to be using the standard library. Instead, we want to use this. So you're importing this. Use Soroban SDK. That is what we want to use. And so these are what we're going to be using. Going to be using the contract, because we're dealing with smart contract, and the contract implementation and vectors, environment, string, and vector. So environment is basically the place, the blockchain environment itself is where everything is happening in the blockchain. And string, you probably know what is string. So Soroban has its own version of string that comes with the Soroban SDK. So this one is not to be mistaken with string from Rust itself. So this is string that is created under the Soroban SDK. Another thing also you notice here is after we imported the Soroban SDK, we use this contract. So what does contract do? So contract just defines that, okay, whatever is under here is a contract. So we're going to create a contract that is called, in this case, our contract name is contract. So pub struct contract. And here, the other part here is the implementation of the contract, the functions and all that happens here. How are we going to implement this function? What's going to be happening? And this is where there's going to be all the methods that you're going to be creating, like we talked about previously, the functions and all that. So inside the contract implementation, you'll see that we have created a function. When we use in the previous classes, we're just creating functions this way, like function hello, and then the vector and whatever. And then here you have what you're going to be returning, the type of what you're going to be returning. And here is what you're actually going to be returning. There's slight difference when you write in smart contract. Here you can define whether something is private or public. So if you just write it like that, then you won't be able to call it outside. So you have to specify that it's public. And here you see we have a method. We have a parameter here that takes two things. We take the environment. This just specify that where we're going to, where Soroban is going to allocate our data that we're working on. In this case, we're working with string. The string is going to be our parameter, and we're working on the environment, and it's going to return a vector that is a string. And just like Rust, the way we type out Rust when we dealt with vectors, you have a vector that has two things. So the first thing is this, but here we write three things because we didn't for environment. We have the environment, but what's actually going to be printed out is these two things here. We have this part, and then we have this part. Can somebody just guess, just based on what we learned from Rust, if you just look at this code, like knowing what you learned from Rust, what is going to be printed out? What exactly is going to be printed out? Can anybody shoot an answer? And this is, let me further show you. Maybe this is going to help you. This is a test code that's going to test the code that we are writing. So it's going to take this function. So which function? What's the name of the function? So the name of the function is hello. So we're going to use hello. So we're calling, so the word is going to be hello, and then we take dev here. We're taking dev in this instant. So dev is going to be the 2 that is here. And when we return, it's going to be returning a vector that is the hello and the 2. And the test here is basically telling us it's dealing with testing the case. So what if we say let word equal, we go client hello, and then we enter the parameter that is dev, and assert. So you have to make sure that the first string must be hello and the second string must be dev. So whatever we're going to print out, the first string must be hello, the second string must be dev. So that's why we're going to be checking. So let's go back here. Let's save this and let's test it. So cargo test is going to compile it and then test it. Okay, it's taking some time. Okay, in the meantime, before we end and while it's still compiling, let me just do a quick recap again. So when you writing a smart contract on the standard library, and we're using Soroban SDK, and under that, we also have to specify that we here under this we're going to specify define a contract that is called contract, and currently empty. But how do we implement it? Where are we going to implement it? This is where this line comes in. And under that, we're going to implement functions. We're going to have all the callable contract methods and so on and so forth. And we have the environment. So this is the blockchain environment. We have under the function hello, we have the environment, blockchain environment, and then we have the string. But when you're using this method, we're not going to put a environment variable. We're not doing that. We're not going to put like a variable like we done before. So this parameter is basically just taking one thing that we can see, which is a string, and we gave it a name called 2. And the environment is the blockchain environment itself. And inside the function, we're creating a vector because we're returning a vector that has a string. And this vector is going to be returned, and it's going to have hello, which is converted into string. So we get hello, and then we convert it into string. And then we also take the 2 here, which is going to be another string. So the result, the expected result, is just going to be a vector because we didn't specify, we didn't like get a key from the vector like we've done in previous classes. You can use a vector, and then you get, for example, I can only get hello, I can only get 2 alone, or I can get both of them, but I format it in a way that looks beautiful. We're not doing that. We're just returning the whole vector as it is, as ugly as it is. That's what's going to be returned. And you will see how it will look like. So the expected output will be this. Let me show you. So this is going to be the output. It's going to look exactly like that when we run the code. Hello dev with bracket and all that. So it's not looking very pretty. We're just printing out the whole vector. So that's what's going to happen. That's what's happening here. And here we basically telling that whenever we're going to be running this, we're going to be running the test. We will be, whenever we write the command cargo test is going to test, we're going to go to this file and we're going to run the test. And this test simply takes in a word, whatever word. I can even change it to whatever, maybe James, for example. So if I take James and then assert equal, so it has to also be James under here. So here we're just calling the function from the library, calling the hello function, and we inserting James, we convert it into a string, and then we basically telling that this must equal to, the output must be the following: hello, James. If it's not the case, then it means that our code is not working as it has to work. Does it make sense? This is like you just going a step ahead of, just a little step ahead with the way we work with Rust itself, the way we've learned so far how we're dealing with Rust. Because we're using specific ways of using vectors. There's specific ways of using vectors and string, and that is slightly different from using string or vector from the standard library, from Rust standard library. So this is gonna keep on building and building, but once we're done, I don't want to take much of your time. Once I'm done with all this, it's going to tell me that the test is passed, and you can go further. You can go further and deploy on the test net. So this you can do it on alone on your free time, or maybe tomorrow we're going to do that. So after we're done, you can deploy it on the test net, and you can play around with it and change the names and change whatever. Yeah, this is something that we can do tomorrow. But for exercise, this is not a homework. This is just for practice sake. Make some changes. Instead of writing hello on the test, write hi, for example. Just make some new some modifications and see what happens. Yeah, so that's it for today. Any question before we leave?
The PDF that you started with at the beginning of the lecture, do you have that? Are you uploading that to the Google Drive?
I'm going to upload in the Google Drive. I'll do that.
And then can you just share the link again with us in WhatsApp, if you don't mind?
So
Cool. Thank you so much.
you're welcome. So tomorrow we're going to continue with simple project on smart contracts, simple smart contract, and next week we're going to build a project together and see how it goes. I don't know if we'll finish next week. I don't know if we'll be able to finish everything next week, but we'll see. Because we'll see how it goes. But thanks for coming. I'll see you tomorrow, same time. and have a lovely evening.
Cool. Thanks a lot, Ben. Enjoy your night. Cheers,
You
guys.
too. Cheers.